All right. Thank you so much. Really appreciate it. I'm really grateful to be here. And for everybody listening in, this is going to be a fun talk. As was said, my name's Jeremy. I work as an engineer at Synadia right now, but I've worked in a ton of different industries and in a ton of different roles. Recently coming back from a long stint working as a product executive. So I'm really excited to engage with anybody who's listening in, who's a leader right now, a decision maker in terms of IoT, and really trying to figure out how their organization can continue to innovate as we're starting to come up to some really interesting problems in the space as we start moving out to edge. So I'm really excited to talk about that in the context of business, but also in the context of I'm a big nerd. Like I'm an engineer by trade. I still love it. And there's this technology that I'm going to talk about today, NATS, is just one that I think is going to be very important as we continue to move forward with getting everything in the world more seamlessly connected to each other. So I'm going to go ahead and share my screen. Like I said, I work at a company called Synadia, and we maintain a project called NATS. So I'm going to be talking a lot about NATS today, but not just about NATS. We're going to be talking about some of the problems that come with us trying to move a lot of our stuff out to the edge, and really trying to challenge us to rethink how things connect to each other, how we've been doing things, kind of get an analysis on that, and maybe propose some different ways of thinking about solutions to those things. And so I'm going to get us kicked off right away. I said this was a fun talk because it's going to be pretty interactive. So NATS is an adaptive technology, and so is this one. So I want people to weigh in on where they're at, and I can adapt the talk accordingly. We have so much content to go over, so adaptation is needed. Now, when you visit this website, which is grandslam22.vercel.app, take out your phones, take out your, open up another tab in your browser, fill in your name. If you don't want your name to be exposed necessarily, use a pseudonym because we will be showing this on the presentation. But I'm going to go fill out my name. I'm just going to say Jeremy, and I'm going to fill out this survey. How familiar am I with NATS? I use NATS in production. What topic am I most interested in learning? Well, I would love to talk about NATS at the edge with leaf nodes. We'll have some time for that. And how familiar are you with the edge? Well, I'm running at the edge, but I also have felt the pain with developing things at the edge because there's still a lot of pain. It's very early, and we're still trying to figure out what it means as an industry. So let's hit submit, and hopefully we'll start seeing some other responses come in here in real time. Yeah, it looks like we have somebody else responding, which is great. And I'm going to just leave this to it. So again, if you're just coming in for the first time, what we're doing here, visit grandslam22.vercel.app and start filling out that survey. And you can see the survey results, come in real time. And looks like we're starting to get some survey results here. Keep this browser window open because this is actually connected to a NAT server that we have deployed here over in Austin, Texas. And we're going to actually start using this as a way for us to communicate and connect with each other throughout the talk. So great, awesome. It looks like we have 50-50 on people who are familiar with NATS, who have some familiarity or are using it in production, or complete newbies versus using it in production. We have people who are interested in global scale, lots of people who are interested in leaf nodes, which is great. And then folks who are still learning about the edge, or they're feeling the pain with the edge. It looks like we have a good kind of diversity here, which is awesome. So I'm going to hop back over to my slides. And the topic of this talk is about rethinking connectivity. We push this idea a lot at Synadia because we see some of the challenges that organizations are facing, especially with moving things out to the edge, or working with multi-cloud deployments, multi-geo deployments. And so we're really seeing this trend that like multi-cloud and edge computing is driving a massive transformation in how we think about not only building applications, but designing systems that are going to meet the needs. And in a lot of ways, consumer expectations are changing and business expectations are changing for how close our compute needs to be to the actual human being on the other end, but also where that data lives and how it's processed is also coming into question a lot as well. And so I want to outline some of what we've kind of analyzed as some of the limitations of today's technologies. The first one being that there's this underlying assumption that DNS and host names and IPs are kind of the way to get machines to talk to each other. And we've put a bunch of layers to try to make this a little bit more ergonomic, but at the end of the day, we're still kind of using IP addresses to get machines to talk to each other. And maybe the that's that's not scaling. We're all kind of feeling that, but maybe there's a better way to do it. We also kind of rely on this idea of like pull-based request and supply semantics, using HTTP everywhere for things to kind of communicate. And maybe that, HTTP was used for web browsers to get hypertext. And so maybe there's some other ways to think about how to still play nicely with web standards, but maybe use things that might be a bit more powerful and suited for our use case. This is a big one. So, when we moved from on-prem to cloud, like a lot of organizations have in the past couple decades, we kind of said, well, our security model is that we'll put everything in our virtual private cloud and like clean our hands and call it a day. And then we have this kind of new trend of edge, really challenging that model. And a bunch of folks are now scratching their heads wondering, well, how do we like really balance security when we have compute and data outside of our own perimeter? Another one is location-dependent backends. It's been with the advent of being able to store large data sets and analyze those, it's really easy to stand up maybe a monolithic backend to be able to store all that stuff. But because consumer and business expectations are changing, and we're now working at a global scale, that's also not scaling as well. So we start asking ourselves the question of like, well, where does this data get stored, and how do we replicate it, and how do we get it closer to the edge endpoints that we support? And again, related to this, a lot of this is just layers built on top of a one-to-one HTTP communication, especially in the case of microservices. But I think there's also many other industries that are kind of plagued with this as well. And so these are some of the problems that we wanted to solve when building NATS. And so NATS, let me introduce NATS for you. NATS is an open source, high performance messaging system, and something that we like to call like a connective fabric. And really the goal of the project is to simplify the number of technologies you use for your services to communicate, while also empowering you to build systems that are globally available, multi-cloud, multi-geo, and they're highly adaptive to scale and change. Now, I know that seems like a lot in a big buzzword soup, but I promise you, really what NATS is trying to solve for is that connectivity piece. If we could rethink how things connect, maybe we can have a better time building our systems that are going to be more resilient. They're going to have more flexible security models. They're going to be able to be much more adaptive to the pace of change that we're experiencing here in this industry. So how does NAT solve some of these problems? Well, one, we really wanted to get away from IP and DNS-based addressing. So we looked at this idea of location-independent addressing using subjects. I think it's really important for the edge when you really want to build services that are truly nomadic, not necessarily just being able to move between one data center to the other, but truly nomadic in the sense where you can move it from some data center on-prem or in the cloud over into an edge site and have it just work. And this was one of the things that we really wanted to solve for at a massive scale. We also wanted to get away from just assuming everything is a one-to-one communication, and we wanted to facilitate communication between many to many, and be able to have flexibility of all that gray area in between one-to-one and many to many. And I think it allows for not only for just some really powerful constructs and patterns to emerge, but the idea of multi-pattern development really being truly feasible with a system like this. We wanted to also just get away from poll-based because poll-based semantics does not scale when you have millions of devices all trying to hit some centralized place. And so push is also another pattern that we wanted to be able to support more natively. Not lastly, but very importantly, we wanted to build a security system that wasn't just based off of building a big wall around your virtual private cloud, but one that could use modern cryptography techniques, modern security techniques, some zero trust constructs to be able to build a true multi-tenant and decentralized security model. So very, very fun. I wish I could talk about that. I could totally talk about it for hours, but I have not enough time. The last one is this idea of intelligent persistence. And so, when we have communication or messages flying all around, how do we persist those messages in an intelligent way that could be replicated easily across multiple geos, across multiple constructs that can be filtered and muxed and demuxed? Once we have our data stored, stored, that's just the beginning of it. Being able to figure out where it goes and how to put it in motion and how to replicate it is the other big thing that we want to continue to solve for. And then we have this global scale that we wanted to solve for. We didn't just want NATS to be something that you put in a data center and now it's your kind of pet that you have to take care of. Instead, we wanted you to be able to Lego brick these things together and really create a web or a global deployment of this thing where folks can get the latencies that they want, no matter where they are in the world, and that it's feasible to be able to scale out to a very, very large number of connections. And so I talked a bit about some of the goals and what we're solving for, but let's talk more about the practical aspects. So like, what is NATS? Well, NATS is a simple client server architecture that essentially brokers messages. And with these smart layers and goals that we had, we've layered on top a lot of really interesting bits that make this very, very powerful. But at its core, we have a NATS server, which is simple, it's small, and it's easy to deploy. It's written in Go. And this is a really important part because a lot of messaging systems aren't tiny, or especially ones that have persistence and storage or act as append-only logs. And so one of the things that I think works really well with NATS at the edge is that you can put this on a very low compute device, like Raspberry Pi-like devices. And so I want to illustrate why that gets powerful in a few minutes. But lastly, the client piece, we support over 40 different client libraries in different languages. And so you can kind of rest assured that NATS can act as kind of your central nervous system for no matter how the applications are built or configured, that most everything can speak that language, and you could use that as your universal language for having things communicate with each other. So let's talk about the very core of NATS, just like the very base level of like the atomic message unit and how that works, just NATS messaging in general. And then we'll start layering on some other pieces, things like global deployment, persistence, leaf nodes, etc. At its core, NATS is just a fire and forget message publishing system, and the NATS server brokers messages between these things. But where it gets interesting is in some of the patterns, which we'll talk about in the next slide. But NATS is very fast. It scales to millions of messages per second on a single instance, which is awesome. And we also use this idea of subject-based addressing, which allows you to kind of use a common language for services and streams. And then it allows you to still use all these similar patterns and build in a similar way, but scale out to a global deployment where things are run efficiently. And we could find the closest responder and we could easily load balance, et cetera. And the NATS core, like I was mentioning before, NATS at its core is securely multi-tenant, meaning you can manage, multiple logically independent or logically isolated accounts that can do their own thing. You can connect those accounts, but that you have a security model around that. So you can actually operate NATS as a public utility inside of your organization if you want. And we, Synadia, we operate a global supercluster of NATS, a full global deployment that you could actually sign up for and use. It's called NGS if you want to play around with it. But we've really solved what we call this Coke and Pepsi problem, where we can have two organizations on the same on a same system, but completely logically isolated. If you do want physical isolation, by the way, I'll talk about leaf nodes in a second, but that's another really good way to achieve physical isolation. Okay, so what are some of the NATS core patterns? Again, we wanted to get away from just assuming everything was one-to-one communication and just poll-based. And so we support things like, request and reply like you would with HTTP. Given that we're a messaging system, we also support publish and subscribe. Fan in and fan out patterns are very easy to model. And another interesting part is this idea of load balancing via queue groups, not just load balancing your services horizontally, but also being able to kind of load balance around the globe, where NATS will, through this kind of design, will be able to locate the closest responder to your question, which gets very, very interesting because you might be on an edge device and you might notice, that you're getting latencies to this service that are kind of tromboning back and forth to the cloud. And one easy way to solve that is you could just pick up that service and you could put it in your edge site and get much quicker latencies. And really, that's the magic that we wanted to create with something like NATS. Okay, so I'm going to jump into a really quick NATS core demo. Hopefully you guys still have that website up, this one here. What I'm going to do is I'm going to jump into my terminal, and just to show you real quick how easy it is to fire up a NAT server. It's like that. You just type NAT server and have it installed. It's really easy and lightweight. And just to show you guys like that NATS is fast, I'm going to run a NATS bench against the server that I just fired up. I'm on a Mac Studio, but you could see that 6.3 million messages per second. So you can really do a lot of high performance messaging, and that's just on a single server that I just fired up on my Mac, which is really, really neat. And so that's the performance, but let's get into interacting with this demo that we have. I said we have request reply, we have publish subscribe. I'm going to use the request reply semantics to actually do some fun stuff with folks who have their browser tab open or
By the way,
that.
Jeremy, we're still seeing your slides in case you wanted to switch over.
Oh, okay. That's good to know. Thank you for letting me know. There we go. That should be better. Let me share my full screen. Okay, there we go. I'm over in my terminal now. I'll run another NATS bench just to show you guys how fast this is. 6.3 million messages per second in that run, which is great. I'm going to go over to my terminal and I'm going to start interacting with that tab you hopefully have open or open on your phone. I'm going to kind of demonstrate what it looks like to do end-to-end communication. So I'm going to do a roll call. You can't do this with HTTP, but you can do this with NATS, which is really cool. Everybody who's connected is kind of acting as a little edge device or a microservice. So I can say NATS request grandslam.rollcall, say who's here, and hopefully I should get some folks going through here, listing out that kind of roll call. I also mentioned this idea of load balancing. And one way we could illustrate that is I've created a little lottery endpoint that everybody's subscribed to, but they're subscribed to in this idea of a queue group for load balancing. And so I'm going to make this request to see who the winner is. And it looks like Bill A is the winner. And hopefully Bill A has some confetti going down their screen. It looks like I am the winner for this next one that I just fired up. So let me see what that looks like. Oh yeah, so I have some confetti going down my screen and you can kind of see some things show up in your log here. So this is just a really cool demonstration of, we're using NATS over web sockets to be able to connect to that NATS server. But this could be a microservice. This could be a service inside of an edge device. It could really be anything that's connected into NATS. And you could, again, run this very securely, which is really, really awesome. Okay, I'm going to hop back over to, actually, before I hop back over to my slides, I'm going to jump in and just show you guys, if you refresh that page, you should be able to still see that the survey results come in. And that's because we're not using fire and forget message publishing for the survey results. In fact, we're using what we call Jetstream, which I'll talk about in a minute, to store these messages and persist them. And so I can actually look at that. I could look at that stream saying NAT stream info grand slam, and I can get information about it, how many messages have come in there, how many active consumers, which is basically how many browsers are open and looking at that, which is neat. And I can also pull in those messages really easily, NAT sub stream grand slam, and now I have a persistent consumer connection to that stream. As soon as new survey results come in, I will also get them in real time as well. So a lot of really neat kind of constructs that you can build on top of NATS. Okay, let's jump over to my slides again. And I want to talk about intelligent persistence with Jetstream. So Jetstream is a next-gen persistence layer built on top of NATS core that stores these messages in an ordered way, which is great. It's multi-tenant, it's highly configurable, and it's globally scalable. So one of the things we wanted to do with Jetstream is we wanted to look at all the ways that these messaging systems are storing messages or how things are just getting stored in general. We wanted to try to solve like 80% of the distributed computing problems with kind of a single monolithic idea or monolithic architecture of like streams and consumers where they're so highly configurable that you could build you can really build whatever there. If you want to build, a queue or an append-only log, or you want to just do replays on your services, or you wanted to perform any sort of roll-ups or compaction. There's a lot of different ways that certain technologies will will approach this. And we wanted to be a little bit more broad in our application, because we really do want NATs to be used, and we see it being used in a lot of organizations as kind of this central communication nervous system. So if you could do things like key value stores and object stores and queues and logs and all of that stuff in one system, why wouldn't you? And so that's really how we designed it. So you get to be able to build these streams with multiple types of consumer models, multiple qualities of service supported, at least once, exactly once. And so at most once with just core NATs, fire and forget. We also have a really cool story about how we replicate this data with digital twins and with sourcing. Inside of that replication, you could also mux and demux data. So imagine you have a bunch of edge devices that might have their own streams inside of their own NAT servers, but those get stored and forwarded into a much larger stream in the cloud that can then be processed and have decision making happen there. The opposite could happen as well, where you can have one big stream in the cloud that then filters down into a stream inside of a leaf or inside of an edge location that is data that's only relevant to them. And so you can do some really, really neat and interesting things with these streams. Lastly, I mentioned key value stores and object stores. When you store a globally ordered set of messages, you can do some really interesting things with them, like create other types of data access patterns and data structures. And one of the things that we really wanted to solve for was creating a globally replicatable key value store. And that's exactly what we did. And we've seen a lot of usage with that because KV stores make a lot of sense for developers. They can just go look up things really quickly. And that's all built on top of this idea of highly configurable streams. Okay, just checking how we're looking on time. I think we're looking okay. Let's talk about deployment. What does NATs look like at a global scale? And I want to start with just topologies in general and work our way up to what it looks like to build out a NAT system and how flexible and adaptive it can be. So when you're running NATs as a single server, like I showed you, millions of messages per second. We've seen NAT servers flood, 70 gigabit NICs in terms of throughput. And then you can move on from a single server to then a clustered set of servers for durability. They're very easy to cluster, which is great. They're fully meshed. As you go from a single cluster, maybe in a data center, and you want to start thinking about what it looks like to be global, you can then extend those clusters into superclusters that have gateway connections that basically allow these clusters to act as one big system, but spanning the globe. And so you can get much better latencies and interactions with clients that may be existing not close to where the original cluster was, because now you have clusters all over the globe. And I'll kind of show how that looks. The last one, which I think is really important for IoT, is this idea of leaf nodes, and we'll go a little bit deeper into leaf nodes in just a sec. Okay, so this is kind of the idea of what a single server deployment looks like. You have multiple NATS clients that connect into a NAT server, and NAT server brokers their messages and store streams and does all that really neat stuff with it. And then a cluster, looks how you would maybe expect it to look, where for durability purposes, you can cluster these NAT servers together. So if one goes down, clients automatically know about the server's peers through our gossip protocol and can switch over, fail over automatically, which is great. So NATS is very good at self-healing in that regard. From a Jetstream perspective, you could also easily, create replicas of your streams on a cluster. So I can say, hey, I want this stream to live on all three of these, and be replicated. So if one server goes down, I still have access to that stream and a new leader is reelected. This is just an example of, you don't have to do 3-node clusters. You can do 5-node, 7-node clusters, and they're all fully meshed together. Superclusters are where it gets really interesting, because you can then take a localized cluster in a data center, and you can either make it cross, geo, like across the globe, or you can cross data centers or even clouds with it. We have a lot of customers that will do multi-cloud deployments in that case, where they want to have clusters in each kind of cloud. So if a particular cloud outage happens or multiple availability zones in a cloud go down, they can still make sure NATS is up and all of their communication and their data is safe. Lastly, we have leaf nodes, which I think is the most interesting bit and the most applicable to our IoT use case, because the supercluster kind of assumes it's all one big NAT system under its own kind of security model and its own operational model. But leaf nodes kind of defy those rules in some really interesting ways, and I'll talk about that in a sec. When you put all this stuff together, this is kind of the deployment that you start seeing, where you have kind of a centralized supercluster that may exist in the cloud, but then you have these leaf nodes that may exist in edge sites and retail locations and factories, and clients can connect to either of them depending on their context. And so, this client over here might be requesting a particular service and a service endpoint or subject, and the responder might be all the way over here, but NATS will intelligently route to that. And you'll notice that latencies might be higher, even though NATS figures it out. And that's some insight for you to be able to be like, oh, well, maybe we need to deploy this service closer to who's interested in it. So I could deploy it here inside of this cluster in the cloud geographically, or I can even deploy it on this edge site to get very, very tight latencies. You have a lot of control over how these things communicate with each other and how to bring compute and insight like closer to who needs it. So I talked a little bit about it, but let's talk about NATs at the edge with leaf nodes. So what is a leaf node? A leaf node is an extension to a NAT system of any size. It supports separate operational and security domains, which means you can bridge two completely different organizations or security models together. And it can operate normally without a connection to the hub, which is really important in IoT, where spotty connections is just a part of the game. And so figuring out how to do things like store and forward and command and control are things that you have to reckon with. And I think NATS makes this a lot easier. So what are leaf nodes good for? Extending a hub and a hub and spoke topology, where you have your hub as the cloud and maybe your spokes are things that are edge sites or edge devices. It's really good at also just bridging like NAT systems together. Maybe you have a partner or an OEM that is also running NATs and you want to all speak a common language. You can bridge those two together. And then especially with connectivity at the edge, it kind of enables some really interesting patterns. Store and forward being one that's really common, where you'll have a stream inside of a leaf node and you'll just treat it as your own kind of stream, but then you can configure the hub to say, hey, I want to know, I want to get updates to that stream as well. I want to replicate that stream maybe inside of a bigger stream that replicates all of them or muxes all of them. And store and forward just happens automatically. I think that's a really, really huge use case for folks in IoT. Command and control is another big one, being able to know which leaf nodes are up and what you can call inside of them. We see a lot of people use this for fleet management and command and control as well. Some more use cases. I like to break this down to like location-based, and this is stuff that we've actually seen. So like factories to the cloud, factories running their own set of services, but then figuring out what kind of data they want to be able to like store and forward to the cloud, or even what services they need to interact with in the cloud. Same thing with retail sites. Retail sites are super interesting because their service footprint locally can actually be quite big. But they also interact a lot with the cloud. And so that's another really cool use case for leaf nodes. Planes, trains, automobiles, satellites, stuff like that. All those use cases are ones that we love exploring because they present these very interesting problems that we think leaf nodes are well positioned to solve. More operationally, like if you have like partner sites, OEMs, or multi-prem deployments, anything that kind of like gets a little sticky in terms of like these are two separate organizations or departments or security models, operational models, you can use leaf nodes to bridge those two things together and have them all speak the same language. So I want to bring back, before I close, this idea of like, this is what you can start really small with a NAT server and a couple clients, but you can scale out to this global massive scale where you're running a supercluster with all of these leaf nodes in there, and NATS handles it really gracefully. It's really fun to see kind of a holistic view on like, how could we connect the world? And this is something, this is a technology I think has a lot of legs in terms of really challenging us to rethink how stuff connects to each other and how we can do it on a really large scale, and how we can do it in a way that really adopts modern zero trust, decentralized constructs in a lot of ways. And so that's the end of my talk. I know I have a few minutes for questions, so I'm happy to answer any questions that show up in the Q&A.